Okay, welcome back to the problem solving of the questions from the past paper of the CIE for A level about the momentum. So state the principle of the conservation of the momentum. So is this question? The answer is that the total of the momentum is constant. So the total of the momentum is constant, or momentum before the collision is equal to the momentum after the collision. Show that the speed v of ball y after the collision is 8 meter per second. So we're going to find the answer. So m1v1 or mx mx is 0.24 kg. So we don't use the unit here, times the velocity, which is 16, plus the y, which is in stationary, which is 0, is equal to py, which is my vy. You know that the my is 0. So x first, because the x after that collision is stationary, so 0 plus my vy, which is 0.48, times the vy that we are going to find after the collision. So by this calculation we will get that the vy is equal to 8 meter per second. Next question, calculate the change of the kinetic energy of the collision. The delta kinetic energy is equal to half times the changing before and after. So mx vx square minus my vy square. So this half, after that calculation we are going to divide it by 2, so equal to half times, in the bracket, mx, which is 0.24, times vx, which is 16 square, minus, which is 0.48, times vy, which is x square. Okay, and we solve this equation, and then we will get 15 joules. Okay, because the kinetic energy is the changing of the kinetic energy before and after. The next one is about the magnitude and direction of the force X. So the force exerted by ball X is equal to mv time divided by delta time. It's equal to 0.24, because mass X is 0.24 here kg, times the velocity, which is 16, divided by 2 millisecond, which is minus 3 seconds, and the answer is 1920 Newton, and the directions is to the left. Why to the left? Because this is X, Y. The Y give force to the left, to the X. When X give force to the right, to X, this is the third Newton law. The third Newton law, which is action is equal to reaction, but different opposite, in the opposite direction, but equal magnitude. So compare the magnitude and direction of the force exerted on ball Y by ball X during the collision with the answer. No further calculation are required. So as we know that the action and is equal to the reaction, which is talking about the magnitude. So equal magnitude. How about the direction? Direction is in the opposite direction. Okay, so this is going to the right, this is going to the left, but they equal. So if this is F2, this is F1, so F1 is equal to F2. Okay, I think that's all. Thank you.